Hello and welcome to my next video. In this one, I will show you what exactly Kotlin operator overloading is, how we can use it, and what's even more important, what value can it bring to your project. Without any further ado, let's get to work. So, what is operator overloading in Kotlin? Well, operator overloading is nothing else than a possibility to provide a custom implementation for a predefined set of operators on Kotlin types. Let's take a look at the following example to get a better understanding of what I already said. So, let's introduce a new data class and call it example class. This will have one field called value and let it be integer value. Enter. Nextly, let me create an example operator function. So operator function plus and other value. This will be integer as well, and as a return type, let's specify the instance of example class. So right here, let me create a new one. This value plus other value. As you might expect, as a result, we will create a new instance of example class, which value will be set to a sum of other value and the already set value. Nextly, let's get back to main and introduce a new variable. Let's call it 1 equals example class and let it be 10, for example. The next one will be called 2, and this one will simply go with 1 plus 11. Nextly, let's print out the value of 2. So print on 2. This time, if I run the application, we can do the same with Ctrl plus Shift plus F10. Let me open up the terminal. As we can see right here, a new instance with 21 was created, but what's even more important, instead of invoking manually the function like 1 plus 11, we simply use the plus sign right here. And of course, this is only one of the many operators we can work with. What's worth mentioning here is that we can implement our operator using both member functions, just like we did right here, or alternatively, we can create an extension function. So let's rewrite that to extension function, operator function, example class, plus other value, integer, return example class equals example class of this value plus other value. As we can see, everything seems to be working as expected, so let's rerun the application, and this time everything is good as well. So to rephrase, operator overloading is nothing else than providing a custom functions implementations for a predefined set of operators for Kotlin types. And I am well aware that this feature will never be a deal breaker when selecting the right programming language for your project. Nevertheless, I still think that when properly used, it can help us maintain code readability and achieve a more expressive and natural code base. With all of that being said, let me delete this example right here. Also, let's remove these lines. And finally, we can start the practice part and learn Kotlin operator overloading. As the first one, let's take a look at the invoke operator, which simply translates parentheses into the call to the invoke function. So let me implement some handler, class, some handler, and this will have a few functions. So the first operator, fun invoke, and this will return some string value. Nextly, I can show you that this invoke function can take arguments as well. So operator function invoke, and let me introduce some ID of long type equals and some ID, and let's go with string interpolation and put the value inside our returned string. Additionally, we can introduce another variation with the same number of arguments, operator function invoke, and this time string value, this will be of string type, and also some string value, and let me use string interpolation, string value, Ctrl plus Alt L, so we can get back to the main function, and let's make use of our handler. Val handler, let's create a new instance, some handler, and nextly, instead of going with handler, invoke and providing any parameters or not, we can simply invoke the handler itself using parentheses. Let me print out the value, println handler, shift plus F10, some string value. As we can see, our first function was invoked successfully. Nextly, Ctrl plus D, this way we can duplicate the line, and let's invoke the second variant, and lastly, value, third variant. Shift plus F10, and we can see that everything is working as expected. So basically, when dealing with classes which truly have a single responsibility and a descriptive name, this becomes an interesting syntactic sugar. Of course, when overriding invoke, we can implement functions taking multiple arguments as well, so this is not any limitation right here. Nextly, let me remove these lines, and let's take a look at unary operators. In this video, I would like to show you 5 of them: the unary plus, unary minus, not, inc, and dec, which are used for incrementing and decrementing. Let's start with introducing a new class. This will be a data class, and I will call it SumText. Data class SumText. This time it will have value of a string type. Nextly, let's introduce 3 operator functions for unary, plus, minus, and not. Firstly, operator function unary plus. Right here, this will not take any parameter argument, some text, and this time we will create a new instance and we will get the value which will be uppercase. So this value uppercase. Nextly, let's do exactly the same for unary minus, but this time I would like to get a SumText instance with a value to lowercase. So operator function unary minus and SumText equals SumText, this value lowercase. Wonderful. Lastly, as a not, I would like the value to be reversed. So operator function not and SumText equals, and SumText, this value, let it be reversed. Ctrl plus Alt plus L, and let's get back to the main function. So let's create a new instance of SumText, val SumText equals SumText and some value right here. Nextly, let's print out all possibilities. So let me close this one. Firstly, we will start with unary plus. So print the value, and in order to get the unary plus, this will be 1 plus sign and SumText. Ctrl plus D, duplicate, minus SumText. And lastly, let's reverse the text. Let me hit Shift plus F10. And as we can see, everything is working as expected. So again, instead of invoking by function name, we can simply use the operators. When it comes to incrementing and decrementing, let's maybe introduce a new data class called custom point, which will be a better example for this particular case. Data class custom point, which will take val x of integer and val y of integer as well. As I mentioned previously, in order for incrementing and decrementing, we have to create 2 functions for inc and dec. Operator function inc, and this will have to return the custom point instance. Whereas in other previous examples right here and right here for some text, the choice was optional and we could return whatever we wanted. In this particular case, for incrementing and decrementing, we have to return the same instance as the data class we have right here. So the custom point of a new instance will have this x value +1 and this y value +1 as well. The same thing we will do for decrementing. Operator function dec custom point equals new instance of custom point, this dot x -1 and this dot y -1 as well. Additionally, there is a bit of a magic happening depending on whether we decide to use a suffix or prefix form when going with incrementing and decrementing. So let's check out an example. Let me delete these lines and introduce a new point. This time this will be variable, not a val. Point equals custom point. And let's start with 0 for x and 0 for y value. Nextly, let's start with println, and let's use the prefixed form of incrementing point. Let's hit Shift plus F10. As we can see, custom point was firstly incremented and returned. Nextly, let's do the same, but start with point and use the suffix version. Shift plus F10. But what's going on right here? We can see that the same value, just like previously, was returned. Well, basically, when using the prefix form, the inc and dec function is invoked first and then the result is simply returned. However, when using the suffix form, then the result is firstly stored in the temporary storage, returned as a result of the expression, and assigned to the initial variable. I can prove you that if I print out the value of point at this point, we should see that it is incremented right there. Let's do the same for minus point, duplicate. This time as well I would like to go with suffix and println point lastly. Shift plus F10, and we can see that right here exactly the same is happening, but instead of increasing the value we are decrementing. With that being done, let's learn operator overloading with Kotlin binary operators. As an example, I will show you how to do the compare to implementation. So let me delete these examples first and let's get back to some text. When working with string values, the compare to implementation is pretty straightforward because basically we will be comparing the lengths of the values. So let me start with operator function compare to. Of course, this will go with other value of the same type, some text. Enter. And as a response, I would like to get the integer value. Let's start with measuring this length. So val this length equals this value length. Similarly, let's do for the other value. Val other value length other value length. Lastly, let's simply subtract the dist length and other value length. Return this length minus other value length, Ctrl plus Alt plus L, and this way we've provided our custom compare to implementation. Of course, depending on your business needs and your classes, you may go with whatever you want in this case. Nextly, I'll simply go to the main function and let me introduce two variables, text A and text B. Val text A equals sum text, and this will be 1, 2, 3. Val text b equals some text 4, 5, 6. Ctrl plus Alt plus L. Scroll down a bit, and let's print out println text a is less than text b. What we should get? We should get false because these values have the same length. Wonderful. If I go with this one, this time I should get true. This is working as expected. The same way this is working in the opposite direction, text b, Shift plus F10, and right now Shift plus F10, we get true in the second case. Lastly, let's go with comparison less than or equals text b, and the same text a is greater than or equals to text b, Ctrl Alt L, Shift plus F10, false, false, and these values are true. Of course, there are much more binary and not only Kotlin operators which we can use for operator overloading, and I will add a link to the documentation in the description for this video. Nevertheless, let's switch to the infix notation, which technically is not a part of operator overloading, but I would like to show you this because this is pretty similar to what we've already learned. Basically, the infix notation is nothing else than the possibility to implement custom infix operations. And even though they do not bring as much as the operators overloading, I still believe they are pretty good synthetic sugar. So let me clean up the main a bit and let's get back to our SumText class and introduce two functions. I will call them coderc, infix function coderc, and the first one will take a string value as an argument, other value, and this will be string value. As a response, I would like to get an instance of some text, for example. So let me go with equals some text, and right here we will use string interpolation. Coderc this value to reference to the some text, colon, and let's inject other value. Similarly, I would like to create another one which will return a string value. Let me hit enter, infix function coderc, and this will take other value as well, but instead of that I would like to go with some text, and as a result, on the other hand, I would like to return a string value. So this time coderc and this value, colon, other value, and let's reach out to the value. Ctrl plus Alt L, and we can get back to the main function. Fun val1 equals some text value. And this time, when I would like to print out the values, I will use the coderc name instead. Println equals 1 coderc and string value, Ctrl plus D, and similarly some text value and an object. For example, let me hit save, Shift plus F10, and this time we should see that everything is working as expected as well. The first function created an instance of some text, and the second invocation created an instance of string. When working with infix notation, we have to remember about two limitations. So basically these functions can take only one parameter, and the parameter itself cannot accept a variable number of arguments or have a default value. So if I go right here and I would like to create some text and default value, you will see that the code will not compile. And basically that's all for this video about Kotlin operator overloading and what this feature brings to the table. As I promised, in the description for this video you can find the documentation where you can learn more about this functionality. If you enjoyed this video, then please leave a comment because I'm really interested in getting feedback from you. Thank you for watching and see you in the next videos.